G'day everyone. In November 2018, the Queensland branch of the AEVA held the EV Expo at the Brisbane Convention Centre. This displayed a wide range of electric vehicles and had a bunch of presentations from experts in the industry. And this video is just a couple of those experts and what they had to say. If you're interested in coming to the Queensland branch monthly meeting, it's on the third Wednesday of each month at 7:30 at the Albion Peace Centre. I hope you enjoy the video and I'll see you on the next one.
It's an interesting time in EV for Australia, and it's an interesting time for Queensland. What we find ourselves in is the genesis point, and we can look back on this time period as the starting point. We were actually there when it happened. We were there when they laid down the plans for the super highway, the charging stations. We were there when we first got, we rallied together and got the first incentives through state and federal government. We were there and we were part of the journey. We were part of that story of the transitioning from petrol to electric. And we're all part of that narrative. We're part of that story. You are part of history. And we're so grateful that you could join us and be part of the best room number 2, just in case you don't know where you are. Yeah. So we're all in agreement. Great time, best room. Please give it up for Francesco de Goro, who will be speaking about how to convert your your petrol bike into electric. Big round of applause for him. Thank you.
Good afternoon, everyone. Thanks for coming on. Today, I'm going to talk about my electric motorcycle design. And even if you don't like motorcycles, you may be interested to hear about some of the tools and the technology I've used in my design. So, first of all, something about me. Since when I was a kid, I've always been passionate about 2 things: motorcycles and electronics. So, it was kind of natural for me to become an engineer and get a job in the MotoGP World Championship. Actually, I had a job when I was 19, but that's another story. So, I spent a few years in there, most of my career, and then I decided it was time for a change. I moved to Australia. So I had to say goodbye to motorcycles and get a regular 9-to-5 job. I was missing motorcycles a lot. So I bought one, but that didn't solve the problem, because it's just a normal motorbike. What I really want, it's something like a Grand Prix motorcycle, but with an electric motor and a license plate. Yeah, maybe that's too ambitious, but when you're passionate about something, you may get close to that, or at least you should try. Why that particular motorcycle on this picture? Because among all the motorcycles I work with, the 250 is the one I like the most. It's the best balanced bike. It's extremely light, extremely maneuverable, and it has enough power. We're talking about something that has 100 horsepower and it weighs 100 kilos. So let's move on. Some 25 years ago, Honda produced this awesome motorcycle that is basically a race replica, but it's a strict legal vehicle. So they took something that is very, very similar to a Grand Prix motorcycle frame, and they built a road motorcycle around it. Great bike, it rides really well, but it has a problem. It is 25 years old. So most of the parts are obsolete. Brakes, suspensions. There isn't much that you could take nowadays. Not to talk about the engine, that is probably the most environmentally unfriendly engine ever designed. It's a 2-stroke, so lots of smoke. So, what can you take? Again, the frame and the wheels, nothing else. You have to start somewhere. So the objectives of my project were to start from that frame and those wheels, install better brakes, better suspensions, newer fairings, and then find an electric motor that will give me enough power to match the performances of the old Honda NSR250. That was quite a fast bike. Then I will replace the traditional harness with a digital switching system. What is a digital switching system? I'll tell you later. It's something quite innovative and interesting. In my project, I will use only and exclusively open source software. So something that you can download for free from the internet, you can use it, it's yours. You'll have free updates forever. And then when it will be designed, I will get it registered because I want to use it on the streets. It's not a race bike, it's something I want to use it. Of course, it is a big project, and I immediately realized that everything had to be designed first on the computer. Every single component had to be 3D designed and put together on my computer to see how it looks like, if it fits, and so on. And the part I had most problems is the frame, because I haven't designed it. It's something that somebody else has made, and it's quite complex. It is a very, very particular shape. So I spent about a month trying to reverse engineer the shape of that frame, and then I said, no, we need a different idea. So I realized there is a really nice technique called photogrammetry. It's about taking pictures of something and having a software reconstructing the 3D shape for you. So I took about 100 pictures of my frame, and then when I had them, I loaded them on a really nice software called Colma, open source again. So all of those red things you see in the image are reconstructions of the exact position of where the photo was taken. And in the middle, you see our frame being reconstructed by the software. I ended up with a point cloud. It's not exactly a 3D model, but at least it's a shape that I have imported from another nice software called FreeCAD, again open source. From the point cloud, I've been able to reconstruct, finally, a 3D model to be used in my project. It has been a nice experience that took me a few months, but I've learned a lot, especially about reverse engineering. At this point, I was able to start designing something, and then I said, okay, now we have the frame and the wheels. Let's try to fit better brakes, triple clamps, new fairing. Okay, that looks more like a modern motorcycle. And then it was time for the motor. So I've done a few research, and it wasn't easy, but I've got what I wanted. So let's see which were the requirements for the motor. First of all, we're talking about a high-performance bike, so it has to be light, and it has to give you enough power. Then, since I want to keep it simple, I'm going to do a direct-to-drive transmission, so the motor can't be too big or can't be too small, that then it needs a reduction gear. So you need something with enough torque, with an external diameter of about 200 millimeters. The power has to be at least 30 kilowatts to match the Honda NSR250 performances, and it has to be AEVA rated because you don't want to get electrocuted when you ride through the rain. So I ended up with this. It's made in Europe. It works, apparently it works really well, and it matches all my requirements. It even exceeds my requirements because the peak power is 75 kilowatts. So it's quite a lot. Let's see how that motor fits on my design. You see the beauty of 3D? It's on your computer. You just design something, put it there, and then it's all about designing it. Couple of brackets. You put there a bearing, because this particular motor requires an external bearing for this particular configuration. And you see the results of your ideas. You can test your ideas without spending a single cent. Well, after that, what do? You think about the battery. Well, let's write down some requirements for the batteries. I wanted something modular so that it can be readapted to other projects in the future. I wanted a battery management system to be integrated on the battery modules. And of course, again, it's something that has to perform, so it has to be light, and it has to store a lot of energy. So this translates in, let's try to fit as much energy as we can on our motorcycle and trying to keep it as light as possible. One important thing, when you assemble battery packs and you do it by your own, sometimes you would like to service your battery, change a cell that is not performing, and that is a big problem usually. So I had to find a solution for that. And at the end, of course, iterating because of electrocution and so on. So which kind of cell to use? There's a number of options, but in recent times, we have this new cell format coming to the market. And that's what Tesla has picked for their Model 3. So there's more and more producers of this 21700 cell. I will be using a lithium manganese cobalt chemistry because that can offer very high specific energy. So we're talking about something on the range of 210 watt-hour per kilo. And in this very moment, when I'm talking, there will be about 10 or 15 companies around the world trying to develop something even better. So the prices are dropping, and at the moment, with the current technology, I could get 7 kilowatt-hour with just 33 kilos of cells. Okay, that all sounds great, but these cells are tiny. They're this big. For a motorcycle like my one, you will need about 500 cells. How do you put them together? Okay, that took me a while to solve as a problem, but I came out with an idea that I like quite a lot, and that's where I'm currently working at the moment on my motorcycle design. It looks like that. It's a module that contains 48 cells. It has an integrated BMS, and it satisfies all my requirements. On top of that, it can also take a slightly different cell format, that's the 2700, because there are other suppliers selling a similar cell to the one that I want, but it's a little bit smaller. I'm not stressing about choosing a particular cell right now, because as I told you, there's a lot of development going on, so it makes no sense to pick something now for a motorcycle that will be built in 6 to 8 months. I will decide it at the very last moment. The only real problem about this battery pack was to actually make it, because I came out with a shape that I liked, but at the end I said, okay, how do you make it? That's too complex to be manufactured. Luckily enough, a friend came to help. He just bought the latest 3D printer available on the market that is able to print fiberglass, so a continuous filament. It's something quite innovative that gives you something very much stronger than the traditional 3D printed material, and it's also stiffer. Furthermore, being fiberglass, it's a very good electrical insulator, so that solved the problem, thanks to a friend who gave me the idea. Let's see how the battery designs fit on our 3D motorcycle project. One click, and you see the result of your ideas. Apparently, it fits quite well. So, let's move on, and let's talk about the wiring harness. Sorry, I forgot one step, the controller. Below the batteries, I fit the controller to drive that motor. Now, let's talk about the wiring harness. On your left side, you see the powertrain. So, motor and controller are out-of-the-shelf products that you can buy. There's not much engineering behind it, except for the setting of the parameters of the controller and driving the controller from the canvas. But nothing overly complex. Then the battery I've designed, and the connection to an external charger. External because being a high-performance vehicle, you can't bring something that it's not useful for your performances. The charger can stay somewhere else. On the top, a dashboard that I still have to design, but I'm not stressing much because it will be a kind of a simple circuit. So I'm planning to do it in the next few months. Shouldn't take me much time. While instead, in the middle, the vehicle control unit, I've been lucky enough that I've designed a board that can do that just a few years ago. So at the moment, it's just about changing the software, the firmware for that board, and the job will be done. So for the center part, we're almost okay. The left part, it's about building the batteries and buying motor and controller. What about the right side of this schematic? Digital switching system. What is that? It is a network of devices that are controlled by the vehicle control unit. So instead of having a harness with relays and fuses to activate your loads or to read signals from your sensors, everything is directly connected to an input-output module that can communicate through a digital bus with the vehicle control unit. So it is a shift in mentality, and this allows you to have a much lighter and versatile harness. Let's try to have a more detailed look on how a digital switching system appears. On your left side, what you have seen on the other graphic, and on the right side, you see the way I like to see the digital switching system. It's a completely new concept. All your inputs and outputs are connected to something that is controlled by a software. So you can change the way your harness behaves, just changing the software. Which are the advantages? You have no fuses, no relays, so more reliability, less weight, and lower costs. And then it is a modular system, and it is scalable. So if you add more sensors, or if you change the way your harness has to work, you just add a module, change the software, and the job is done. We have been using this kind of technology for the last 3-4 years, and with a great success. So that's why I've decided to bring that to my motorcycle. By the way, that's my everyday job, and my company allowed me to use that technology on my project. This is one of the modules that I'm going to use. This is just a cut-down version of the module we're currently selling. 8 input-output pins, 13 amps. That's more than enough for our needs. What's next now? I still have to finalize the battery modules, especially the electronics. I'm currently working on that. And then I have to build some sample. Then it will be about designing the cooling system for my motorbike, the dashboard, the firmware for the vehicle control unit, but that's not much work. And then the last part, where I will have to learn something new, is the finite element analysis on the brackets, because we must make sure that our motorbike doesn't get damaged when you ride it. You have to demonstrate that it is safe enough to be road registered. How it should look like. Some people try to use the same frame and to make a better bike, of course, keeping the same two-stroke motor. But in any case, that's how my motorbike should look like at the end of my design. To conclude, an overview of the softwares that I've used. Take a picture of this because you may use some of them, you may try, you may do some experiment. It's quite interesting. Well, I'm done. Thank you for your time.
Gaton, which will take us straight into converting a vehicle to EV. Thank you.
Can you hear me there? Can everybody hear me there? Good. Okay, my name's Bryce Gaton. I'm going to talk about the generalities and considerations about whether you want to or want not to convert an EV. So first two questions are here. Who's thinking about converting an EV in this room? That's probably why you're here. Second question is, who here has actually converted a vehicle before? Right, the first lot of people who just ask those, I know some people putting their hands down next, they know what I'm about to say. The first lot of people put their hands up, look at the second lot of people who put their hands up, because they are a really useful resource for the tips, tricks and traps of converting EVs. So all the hands suddenly went down there to the second group. So today I'm going to talk about sort of the reasons why and why not to convert an EV, and why you might actually look at doing something else. Then I'll look for the people that are remaining in that still want to convert. Then I'll look at sort of the EV parts and how sort of the generalities of choosing and the types of construction methods you might use. I'll talk about some of the lessons learned both in my conversion experience, because I've converted a number of vehicles in the past, both AC and DC. And I'll also mention in passing that I don't convert vehicles anymore. I do repair them occasionally for people. And part of that is also staying sane during the process, because I see a few smiles from people who've done it, because it can be quite trying. Okay, starting up, a little bit of terminology. EV types, you have basically 4 general types. Your BEVs, which are battery electric vehicles, your plug-in hybrids, so your PHEVs, and then your hybrids, which don't have a plug, but just fuel, and your fuel cells. When you're converting, you're generally talking about these as your battery electric vehicles. By the way, if people are happy to take photos, but I'm happy to send out a PDF version of this PowerPoint. I'll put up my email address at the end. So if you want to save taking lots of photos on the way through, I'm happy for you to do it. It's just more, you can have the whole presentation. So basically when you're converting, you're looking at doing the battery electric vehicles. Now, first of all, is reasons not to convert. Used to be in the past, you couldn't get one. Now anything between 250k for a Tesla down to $500. And there's about 5 currently available new, 5 more coming, and several numbers are second hand. I can build one cheaper than that. Final parts cost is going to be something like about 25 grand. If you're going to build something with 150k range, good ease of use, really safe, really neat looking car, it's not that cheap. So I can build one cheaper. It should be easy. Well, you take the motor out, put in an electric motor instead, chuck out the petrol tank, put in some batteries and a bit of wire. Yeah, not quite that easy. The regulatory requirements make late models next to impossible to do. And you're going to spend it, even for a basic one, you're going to spend 12 months of weekends. Effectively what it is. So just briefly, maybe not a good idea to convert. You can buy new ones now. They're readily available. That's basically some of the prices and things now. Or there's several coming. So we've got 5 available, 5 coming within the next 12 months, within a few months on some of them. If they're a bit outside your budget, because they're still in the 50s, you can buy a second-hand one. So you're looking at probably 12 grand up for some of the second-hand iMoves now, which is still a lot cheaper than actually doing a conversion. I'm desperately trying to put you off it at the moment. You could even pick up one of the private imports. There's a company up here bringing them in. There's also, they do an ENV, they do the Moyev minicab. They even do the 30 kilowatt Leaf. I think Russ, down here at the front, has actually been lent one. That's a private import, 2017, 30. You can actually buy them here in Australia now as great imports. And if you're really daring, you can pick up one of the Blade Getzers, and you can get them down to about $500 if they're going, depending on condition. Not for the faint-hearted, because every one of them was effectively a prototype, because he never had the money, he kept developing them. Every one of them was always different. So I occasionally end up with them in my backyard, because I'm fixing them up for other people, and they drive me nuts, because no 2 of them yet have been the same. Okay, so you've looked at it and gone, no, I'm not going to convert. Okay, 3/4 of the people are now going to get up to leave. For those of you who might be still thinking about it, there are reasons to convert. And one is the fun of it. It really is fun to drive that car and say, I did that. It's sort of put your foot on the accelerator, get going and going, oh, I built that. So it's really good fun to do it. If you've got a personally treasured car that would be amenable to converting, that's quite a good reason to do it. There's some really good cars around that are worth converting and that have sentimental value. Why not? If it's a practicable solution. And looking at that one there, Jaguar are actually doing a paid conversion to make somewhat less reliable cars more reliable. I actually did this presentation, or a similar one, for the Wolseley Car Club. For obvious reasons, they were thinking of ways of trying to keep their cars on the road for a bit longer than usual. and you can make them a very reliable beast with an electric conversion. Okay, a little bit of background to what is a converted EV. This is taken from one of the manufacturers of the controllers. The basic guts of an EV is central brain, the motor controller, you've got the motor, you've got a battery pack, and a whole lot of bits and pieces feeding into that. As you saw with the motorcycle presentation, there's a whole lot of ways of connecting it all. There's basic right up to the CAN-controlled, quite complex ways of doing it. So there are multiple ways of connecting this. If you want to do the old-fashioned way of just wires between everything, we actually had a saying when we were doing the conversions, it was called ABW. Yes, I can do that, but it's another bloody wire. One thing from learnings in the past, don't ever run a car without the BMS. I didn't do it personally, but I have seen someone that did this, blew up 2 battery packs whilst testing. Yes, this will die. Quite an expensive process. So just one of the learnings all along the way. When you're testing, don't feel tempted, oh, the BMS is not quite connected, but everything else will go. Get that BMS working. Brains of the outfit is your motor controller. They're often they are quite expensive. And one detail there is just be careful, make sure you've got all the right fusing, make sure you've double checked all your wires before you turn them on, because they can go bang and they're not cheap. So, looked at the basics, you've thought, okay, I really do want to convert, I've got a car that might be a possibility. Where am I going to go? There's the old debate, AC or DC for the motors. It always was in the past. DC was the cheaper, simpler and safer to work with because they ran with a lower voltage. These days, even in the more recent past, the AC was more expensive, more complex, ran at higher voltages, definitely had their advantages, but they're also vastly more technically challenging. And when we were doing conversions, we started doing AC conversions about 10 years ago. You had to be basically an electrician to be able to understand the complexities of it and get the things working. These days, as I'll talk about, they're a lot easier. Because now, there are lower voltage, simple to wire AC kits available. You can buy a kit and it's just plug and play. I'll talk more about those in a moment, but they're available. The advantages include you can water cool them for the motors, you can have regenerative braking very easily, and totally programmable performance within the parameters of the AC motors. Batteries, again, used to be, was lead acid or lithium. These days, it's pretty much, you've still got 2 choices, but it's all lithium. Lithium is certainly the best choice. You wouldn't go lead acid for a whole lot of reasons. They're just very heavy, give you low range, and very messy and very short-lived. Lithium these days have really good battery management systems. Come back. Pricing is coming down, as you would have seen in the SCA presentation. They're getting cheaper and easier and smaller and lighter. And there is still a choice between 2 things. So you can either buy a new lithium pack, or like those yellow blocks up there, or you can buy second-hand Leaf or Tesla cells. And that one in the middle, that silvery one, is actually a Tesla pack. And the one on that side is actually a Leaf pack, and you can unpack each of those as modules. And I believe Graham up here has been in the past, although I can't get that at the moment. It was actually buying and unpacking Leaf cells and selling the modules. And the same with lithium packs, you can actually get those modules imported from, America's obviously a lot of Teslas and they're getting a number of them crashed, so there's actually battery packs being disassembled and you can bring them over here as units. Okay, we've looked at whether you want to do it, whether the motors, the batteries, the car itself. The vehicle needs to be able to accept the batteries to the range you want. So if you're doing a really mini car, you also have mini space for putting in the batteries. So you've got to think about that. And you've also got to think about, if it's a mini car, it's a lightweight car, you're going to be potentially compromising the gross vehicle mass. I'll talk a little more about that in a moment, but the gross vehicle mass, GVM, is something not to take lightly. If you exceed that, A, they won't register it, or if you're coming very close, you have to start taking seats out. Ross Blade, with the Blade converted Getzes, he would actually take out the middle seat of the 3 seats in the back and took out the back seat belt and put a bolster in there, so to prove it was only a 4-seater, not a 5-seater, because they could improve the GVM because he'd increased the weight of the car with the batteries. As also weight balance is an issue. So again, I'm doing generalities. There'll be a couple of other talks today about the specifics of things. And again, if you want to know the specifics of a particular car, back to that first or that second group of people that have actually converted cars and ask them in detail. Don't hang the battery boxes behind the rear wheels or directly behind the grille. Don't bolt them to the chassis. I'll talk about that more in a minute. Really big one that people get really swayed about. I really want to convert this car. Some cars just don't lend themselves to being converted. We got talked into converting a Mercedes Sprinter, which is a rear-wheel drive vehicle. I would never do it again, because being rear-wheel drive, we ended up building 6 separate battery boxes to get around the chassis and the tail shaft. The Citroen Berlingos we were doing, you could basically cut out a big section of the back, one big box, much easier. So if you're really passionate about doing this car, but it really will not lend itself to converting, please let go of that car and then pick something else. It can be very hard to give up that emotional attachment to a particular car you want to do, but some of them just won't convert, or not sensibly. A couple of other pointers. If you're looking at a post-1995 car with crumple zones, airbags, ABS, yes, you can do them. They get trickier in some ways, but so long as you don't cut the yellow wires, the ABS systems or the airbag systems, you're fine. Crumple zones therefore mean you have less space for putting in batteries, because you're not going to put them right in the back or right in the front. You have to keep back a bit. But they can be done. Post-2011 cars are definitely big boy territories, because they're very much completely integrated systems as far as the traction controls. So ABS, so anti-skid brake systems, are discrete units. They're not so bad to deal with. And Ross Blade did those with his Getzers quite well up till about 2011. But he never couldn't convert post that because of the basically integrated systems, the anti-skids and self-steering type systems under braking, which are just too hard to do. There was a business called EV Me, and we're doing a Mazda 2. I think they spent $2 million converting a Mazda 2 to get all of that software control replaced with an electric conversion. EV Engineering, who did Commodores, post-2011 Commodores, they did 9 Commodores. They spent $27 million in development. They didn't like it when I pointed out that makes 9 into 27, $3 million a car. And basically, that's the sort of expenditure you're looking, $2-3 million a car to get the engineering right for all of those traction control systems. So, keep to the earlier cars. Okay, you made a decision, you're going to convert a car. Do it myself, or do I get someone to do it? And as our friends at SE Tony was talking about, this is that one that they did a Rolls Royce for this lady, and he said never again. But yes, you can. There are various specialist workshops around Australia that will do them for you. So you could go down that path. Yes, I want to convert, but I'll give it to someone else to do. I always wondered, they quoted $25,000. I can't work out how that would have been the parts. So my only thought is it must have been a good friend of theirs, and they thought, yeah, we'll do it for the fun of it, and then realised the mistake. Other option, DIY, do I design it all myself, get someone else to do it, or do I go a halfway path? There are a number of places that will sell you a kit. EV West, this is an American site, will give you, there's about 14 different cars they've actually got kits for you to do. EV West I particularly brought up because they actually do AC kits now. Some of the other places still do DC kits, but as I said, AC is certainly turning into the traction system of choice, in which case that's one place you could go. They're good for first-time converters because you don't have to do all that really hard work design. The donor selection's made for you, so they don't have to work out whether the car will or won't convert. And you can buy partial kits or full kits depending on how much you want to be involved in the design side of it. So you get a modifier add to them. It may not be exactly what you want, but as I always say, doing any EV conversion is going to be compromises. The kit may be the easy way and accept the compromises they've made rather than accept your own instead. Okay, for those who've now that very much small group that are left are going, I'm going to do a car, I'm going to convert it myself, and I'm going to go the whole way and do everything myself. I'm going to talk about some of the things you need to be aware of. Make sure your electrical systems are fail-safe. You know, if you have a crash or something goes wrong, it shuts down and the vehicle cannot be restarted by accident. It has to go through the full restart process. Modern toaster are very much that. If the power fails, the toaster pops up, you have to manually push it down, as opposed to the old toasters, when you pushed it down, they stayed down even if the power failed. That's sort of my analogy for that. I also, with the cars we were doing, we were working with 300 volt systems. We would actually put a series of contactors in to break it down to lower than 60 volts. That's sort of the threshold, the so-called safe, below 60 volts, and it's a higher level of hazard above 60 volt DC. If you can get it to break down in an emergency to less than 60 volts or below, it's just that little bit safer for emergency authorities. Also, the contactors are inside the battery box, so if something goes wrong, it shuts off all power outside the box. How much time have I got left? A couple more minutes. Okay, I'll speed up. I think I'm just about there. And there are many other possibilities. Talk to an experienced EV converter. Designing for electrical safety. A hazardous voltage pack must resist specified G-force. That's called National Code of Practice 14. That was put out by the National Roads Authorities and adopted in various states. Must be electrically completely isolated with a 12 volt system. Colour code must be followed. That must be orange according to hazardous voltage system, NCOP 14, and you don't use orange in 12 volt systems. And the cells must be strapped, etc., to prevent their expansion. Mechanical safety. For the front, you'll mount off the engine bay points, your engine mounting points. You don't bolt to the chassis. The number of times I've had people come to me, can you work on the car? And the first thing I do is unbolt all the stuff they've bolted to the chassis rails and work out a system for putting it onto the engine mounts. Grid GVM I've mentioned. Weight distribution should remain similar to the original vehicle. I always suggest weigh it before and afterwards, preferably at the front and back ends. And calculate your vehicle mass before you start spending money and work out whether it's actually right or wrong. Here's a really good conversion. That's that picture of that Jaguar. They've actually kept everything in the right places. They can pull the whole lot out, put all the mechanicals back of the old Jaguar E-Type, and they actually don't do any changes to the vehicle. So that's sort of a very high level of conversion. Tools, if you're working on tools, the tools aren't all that expensive now. Definitely use fully insulated tools for it. Don't use the spanner set and drop it. Personal protective equipment, you should be working with rubber gloves if you're anywhere near the battery system and it's all connected up. We actually have, I work for Melbourne University with their Formula SA electric race car build. We have all of this is basically pictures of their stuff. They actually have to take this to track day. They have to have a rescue cook, they have to have a face shield. If something goes really wrong, you can go in, gloved up, cutters in hand, and just cut the cables if all else fails. Couple of things, test instruments for EVs. If you're doing a conversion, there are 4 categories of test equipment. There's actually a 5th, which is Dick Smith's 0 rating. The higher the category, the more expensive they are, but the higher the voltage they'll take. If you're working on an EV, Cat 3, Cat 4 only. Do not use the Dick Smith or the Cat 1 or 2. Same thing for test leads. You've got your Cat 4 1000 volt rated DC meter and you put the Dick Smith leads on it. Oops, they will blow up. And certifications, I'm coming towards the end. Certified a vehicle for electric drive, it must be checked by a certifying engineer. There's different processes in every state. In Victoria, we have what's called the VAS system, or Victoria Vehicle Assessment Signature Scheme. At the end of this presentation, I've got all the links for them. Really recommend, if you're going to do a conversion, talk to your local AEVA branch. There are lots of people that have done conversions before, are really experienced in it. As I said, they can give you the ticks, the trips and the traps of what to do and who to talk to, and who to talk to. At the West Australian website, South Australian website I've listed there, they have a really good step-by-step process to get through it. Always talk to your certifying engineer before you start, before you even have settled on the car. Get that communication, two-way communication going early. Document everything. Cars we did when we went to our engineer, we went with the folder that thick. So it was just sort of, we've done our homework, it was just makes things a lot easier if they know that you know what you're doing. And take lots of photos along the way. If nothing else, it makes you feel better when you look through all the photos 6 months down the track and going, I haven't done anything. Oh, yeah, I have. There's all these photos and things going, yeah, I have done something after all. Approval costs, they're about 1,000 to 2,000-ish, depending on your state, depending on your engineer, depending on how involved the engineer wants to be. Some learnings from my experience and from what I've seen in others, don't use cheap DC to DC converters. You'll keep buying them until you buy a good one. Keep the clutch. Engineer your engine mounts very carefully. We have torn them because of the torque of a motor. The engine mounts are the thing that will get damaged. Always have your BMS connect when doing any test work. There are BMSs around that will give you cell-by-cell data. They're really good to look at. Never run a series DC motor without a motor over speed protection. I've seen someone else do that, and I've seen them replace the motor. Because a series DC motor will run, just completely rev itself to death. I would highly recommend having an enclosed, nice flat floor, comfortable workshop, so you can, if it's a part-time project, you can walk away and come back to it. You don't want to be packing up every night. A vehicle hoist is very nice to have. We had one, and ever since I wish I could squeeze one into my current garage. And last but not least, enjoy the process, not just the result. It's a fun travel, it's a fun journey. And ensure there's a well-stocked beer fridge and snacks for your mates when they come around. By the way, beer's only after your work finish. Beers and electricity do not mix. A couple of sort of things, I've put in some references there with the various states, some websites to look at. If you have any burning questions, and my email address is there at the end.